Yeah, it is pretty bizarre. It is pretty strange. They're actually taking it seriously. That's the funny part.
Okay, our next speaker is Mark Andreessen from Mosaic Communications. And what can we say? You know? Mark is a good part of the reason why we're all here. So, Mark Andreessen.
Yeah, so I'm just going to give an overview of what Mosaic is, where it came from, where it's going, what some of the ideas are. This is going to be a very low-tech presentation, just using an overhead projector. I hope it's interactive. If you have any questions or any comments, shoot, go for it anytime. So what am I talking about today? Basically, I'm just going to talk about how Mosaic originally came into being, what it is in the first place, what's significant about it, what it does well, what it doesn't do well, and finally the new company that we formed a while ago and where we're going, what we're going to do. First, I'd like to provide just a little historical context to give you an idea where some of this stuff comes out of. Mark covered a lot of this in his presentation. This is sort of focusing on where the ideas of Mosaic and the web sort of came out of and where I think they're headed. Three really significant ideas that are combining in this sort of explosive growth of hypermedia on the network that we're seeing now. The first is that the original ideas of hypertext and hypermedia, cross-linking of information, and it was really a compelling vision of interlinking all the information in the world and making it instantly accessible to everyone. This goes back into the 60s, and actually prior, President Roosevelt's science advisor Vannevar Bush wrote a very influential paper in the Atlantic Monthly in 1945 where he predicted using completely non-digital, he described a mechanism that was not based on computers at all, because of course computers weren't around then, based completely on mechanical systems and cameras and so on. A system called the MEMEX, where you could link together information. All the information you ever encountered in your life would be linked together in this system and cross-referenced and cross-indexed. So it's an idea that's been around for a long time, and a lot of people have experimented with it and generated systems based on it, including Doug Engelbart, the same person responsible for the mouse and the modern PC in many ways as we know it. The internet itself, as Mark was talking about, isn't exactly new either. It comes out of Department of Defense research in network technology for command and control networks that could survive nuclear wars 25 years ago. So it's been around for a long time. It's been doubling every year for practically the entire 25 years. In fact, one of the interesting things about it is that Doug Engelbart back in the late 60s was the fourth node on the internet. So it all sort of ties in. Sort of the interesting thing about the internet in terms of where it's going is that the internet isn't a wire or isn't really even a network. It's basically a protocol suite. It's basically a set of languages and commands that different computers agree to talk. And they can do this across any set of wires, like Mark was mentioning, cable, wireless, as well as normal telephone lines, as well as future systems. This protocol suite, or this set of languages, is being widely adopted throughout industry by everyone up to and including Microsoft and Apple and all the classic computer manufacturers. And it's this year it's passing the IPX protocol from Novell as the standard for corporate wide area networks and local area networks. So we have every reason to believe at this point that it is the standard for networking for at least the next 5 to 10 years. The third point in the triangle, sort of the topic of this conference in a way, is the multimedia, where it's come from, where it's going. The explosion of graphical user interfaces on the desktop is a big part of all this, of course. And multimedia in this environment, I think, is quickly arriving, and that's going to be a major part of the evolution over the next couple of years. So what happened with this whole Mosaic thing? This is just a brief overview of the chronology. The most interesting thing about this is not necessarily the events themselves, but how quickly it all happened. In '89, Tim Berners-Lee, a researcher at CERN, and some of his colleagues generated for the first time a hypertext system based on the internet called the World Wide Web that was designed to tie together diverse information across the high energy physics community at the beginning, and then eventually expanding beyond that. The early advantage of the system and what they spent the first few years working on was tying in other data sources, tying in other systems, tying in mainframes, tying in high energy physics experiments and data recorders and generators into a system where you could get seamless navigation from location to location across countries, across continents. In early '93, we developed NCSA Mosaic, which was initially only for Unix, which somewhat limited its scope, but because of the characteristics of the net, Unix, the early adopters on the network tend to be using Unix for the most part. So we started with 12 users in early 1993 for our initial alpha release. By mid-'93, when things started to sort of catch fire and this started coming to people's attention, we were up in the hundreds of thousands of users. It happened just up like that. In late '93, Mosaic users were way up there in numbers. Mosaic really started to penetrate the real world, and commercial licensing of that code base began out of the National Center for Supercomputing Applications at University of Illinois. So in early '94, I graduated. Decided to come out to California, ran into Jim Clark, and at that point in time when he was leaving Silicon Graphics, as you probably all heard, he was going to start an interactive television software company, and at that point in time, interactive TV seemed like it was going to be the next big thing, so I was like, okay, that sounds like fun. It took us about 2 months to figure out that interactive TV didn't exist, probably wasn't going to exist, and we probably weren't going to make any money at it. So we recruited all but one of the original NCSA Mosaic developers, a combination of students, staff, undergraduates, graduates, and academic staff at Illinois. And I'm sorry?
What happened to one other person?
Oh, one other person, 2 weeks before we started the company, he accepted a job at another company in Washington, and which unfortunately tied him into a non-compete clause in his employment contract for 2 years. So he works for a company called Spry in Washington, which is a Mosaic licensee.
How many total people did you bring with you from?
6 or 7, yeah. And then we've since expanded on that. We built up the technical team to about 25 or 30 now. The overall company is about 82, 83. We'll talk about that a little bit more later. The impact of the original Mosaic, like I was saying, the interesting thing here is the speed at which it happened and the number of people who encountered it within a relatively brief period of time. In fact, one could even say that the internet was used as a distribution vehicle for a new kind of virus. Actually, there's another instance of this that I'm sure you've all heard of, and that's Doom, which of course has gained fairly great success just by the fact that it just got blown out in huge quantities in its initial form in the network. The virus was an easy-to-use graphical interface to information on the internet. It gave the approximate usage numbers ramping from 12 users in March of '93 up to about 3 million users today. It's hard to say exactly how many users there are of this because it's a completely decentralized, distributed network that's not under anyone's control, so we have no way of actually going out and counting. We can make rough guesses based on the activity that we've seen, the number of copies that have been actually pulled off of the various sites that are feeding it. And what did it do? It linked the native capabilities of the internet, the ability to exchange information among different machines on the internet. Any computer can talk to any other computer directly, which is really kind of a new thing, a new environment to be in. Mosaic exploited that, tied it to the capabilities of powerful desktop computers, including Windows-based PCs and Macintoshes in a way that turned out to be, I think, pretty compelling for real people. The real key to its success and the key to its rapid growth was the fact that people could build applications, information applications, in a way that made those applications very accessible to everyone. You just assume that everyone has this front end, and then you can build a back end that's very specific to whatever it is you're trying to do, whether it's sell goods or services, provide educational resources, serve government information, or whatever it is you're trying to do. I'll return to that later. In a sense, Mosaic is the minimalist hypermedia system. I say that because when we originally built Mosaic, and in fact when the web was originally built, we tried really hard not to invent anything new, and we also tried not to solve any hard problems, which makes it a lot easier to actually get something done. We happily borrowed, stole protocols, formats, code, and so on from all kinds of different places. We dodged all the classic problems. Hypertext and hypermedia systems, like I said, the intellectual origins go back a long ways. There has never been a very successful, broadly used system before I think that's because they tended to concentrate on the really hard problems of building such a system, whereas we just completely skipped them. These problems include things like how do you search across the entire information space? I don't know. How do you know where you are and where you're going? Beats me. So sort of the surprising thing is we ended up with something useful anyway. So we were trying to create something that was easy to use. Fun was a big part of what we were trying to do. We were trying to find a way basically to link people and information together across these networks. So what's it good for? Technically, what we're talking about are as I've probably said 4 or 5 times now, graphical front ends to distributed interactive information resources. People put things up on the net. Other people come along and browse them and grab them. Those other people who come along and browse them and grab them may be just random people, or they may specifically be customers over this class of networks. Mosaic and Netscape provide for display of interactive hypermedia content, at least to an extent. The most common form of content today is documents containing images. Audio and video are in use, but not in extreme, on a broad basis, as is traditional now in the world of multimedia and CD-ROMs. So there's definitely a gap there. On the other hand, Mosaic and Netscape and implementations of the same type of thing are the applications are allowed to span protocols. You can access the same information on Macs, PCs, X Unix workstations, OS/2, Amigas, whatever. And a big part of that is because you have this really cleanly separated concept of a front end and a back end. The front end can run on whatever type of system you want, as can the back end. And they just have common languages, common protocols that they speak back and forth. It's just, in general, just an open-ended use, very flexible use of wide area networks. Provides a universal resource namespace, and all that means is that you've got this network. It's big. You don't necessarily even know how big it is, but you've got a way to point to anything on it. You've got a way to identify that piece of information, that document, that image, and that's a uniform way of locating that image or that document or that piece of information. So collections of those names create applications, and there's because the network is wide open, there's an unlimited number of these specialized applications that can be created. So fundamentally, this adds up, I think, to really being about communication. This is where I start waving my hands a bit. Mosaic really doesn't have much to do with, when you really think about how it's used and what its impact is, it's got aspects of being involved with information and documents and publishing and multimedia and all this, but it's really, the key is communication between people, and that's what the network makes possible. And that's the most important lesson to be learned, I think, out of all this, is that the applications that are going to be successful over the next 5-10 years are the ones that really tie together people. This communication in the Mosaic and the web environment today is largely implicit. You don't send email. You commonly don't use Mosaic as a front end towards conferencing systems and so on. I think that's going to be radically changing. And also, in a very fundamental way, the communication is explicit because anyone can add to the information space. You don't have to get anyone's permission. You don't have to go to any central registry or any central site to be able to add information into the environment. You just create the application, put it up on your server, or have somebody else do that for you, and it's just there. Oops. Flexibility. The most important thing about flexibility of the systems we're talking about are that Mosaic and the web have many, many flaws, which I could go on for hours about, but I won't. Inherently, this is, because of these flaws, ironically, it's an extremely flexible system, and that's what gives it a lot of its power. This goes back to what I was talking about skipping all the hard problems. Because we skipped all the hard problems, it's fairly straightforward to just sort of dodge a lot of the restraints that those problems tended to put around previous systems. And this goes back again. Anybody can inject information into this space without having to log it into a central database or anything like that. You just put it up. That's an extremely powerful concept. A lot of this flexibility comes from the fact that you have a set of assumptions. You assume that all of your users have a universal browser with generic capabilities to display information and interact with people. You assume that you have a cleanly separated front and back end. The front end is the interface, the back end is the application or the server. You assume that the information provider or the content provider or the service provider has total control over the back end within the constraints of what the front end can do. And I was already talking about the implications of the fact that these networking protocols are becoming industry standards, which means that you can build yourself a network using off-the-shelf parts. To use this technology, you can borrow somebody else's, or you can use the whole global internet. Okay, so where's it all going? The flaws that I was talking about earlier, the limitations, a number of them sharply limit the usefulness of Mosaic in its traditional form for lots of real commercial applications, the types of things that businesses would like to do and the types of things that you'd like to allow for services and content to be vended or to be provided in any sort of commercial setting. Some of these flaws include things like security, which Mark was talking about. The ability to interact with users isn't up to the level yet where we need it. The ability to incorporate real multimedia isn't up to the level where we need it yet. So the challenge for commercial vendors of this technology, of which there are a lot right now, this has become a fairly hot field, and there's somewhere between 20 and 40 companies operating in this space. I don't have an exact number. The challenge is to rapidly innovate both the front end and the back end pieces within an open standards environment. One of the advantages of this environment is that the protocols, the specifications, the interfaces are all published, are all public domain, all go through standards processes, so anyone can build products or anybody can just develop software for the front end or the back end that interoperates with all the other implementations of the network. The advantages of this environment for consumers are that you get a very rapid dynamic of innovation as competition in the open environment drives everything forward really quickly and allows the individual pieces to be innovated very quickly. Okay, so what are you guys at Mosaic Communications doing for us? We are our specific focus is on building fast, robust clients, servers, and also supporting tools for creating and running hypermedia applications on wide area networks. We're trying to really build the fundamental pieces that people can take and can plug together to do interesting things over networks. We're trying to address specifically the needs of real-life information and service providers, real people trying to provide content, provide services to customers, targeting both existing and future customers. So this would apply. This would include services that you put on the net for anyone to access and to therefore become a customer of you if they find it sufficiently compelling, as well as to serve your current customer base, depending on what type of company you're talking about. We're trying to make all these services accessible to millions of users, quite a few more millions of users than so far actually, across a wide range of different platforms and wires. And in particular, we're engineering everything for 14.4 kilobit modems because we figured that's where the de facto standard is going to be for the next 3 to 5 years, unfortunately. A lot of our focus is on enabling the concept of private applications over public networks. You've got a public network, anybody can plug into it. You can plug your machine in, you can plug your network in, you can plug your application in. But you can conduct private activities then across this communications channel. We're building full solutions, complete back-end systems as well as front-end systems. Again, cleanly separated, but in a way that you can take our front-end, you can take our back-end, or you can switch out or complement it with pieces of technology from other companies, other sources, and build complete environments. And we're also trying to seed and propel the general environment, continue the pace of experimentation and innovation on the network by, ironically, freely distributing one of our products to internet users, and that product is our next generation browser, Netscape, which you were seeing earlier. I just wanted to share with you the design philosophy of Netscape that we adopted when we started working on it back in June. I'll just read this cartoon. Dilbert says, "We could design the product with a simple point-and-click interface, or we could require the user to choose among thousands of poorly documented commands, each of which must be typed exactly right on the first try. Bear in mind, we'll never meet a customer ourselves." And his boss says, "Make it so they have to reboot after every typo." So that's us. I think we're succeeding at that too. Netscape is a cross-platform hypermedia browser. We really mean cross-platform, and the most significant thing for that, as far as I'm concerned, is that the bugs match across PC, Mac. Geared for 14.4 kilobit line speeds, like I said, but also above. So if you have a fast network, Netscape will certainly take advantage of it. It tries to place a premium on the end user experience, which is really something new. When we originally built Mosaic, and sort of a lot of the principles that this environment is based around, assumes that you have a high-speed leased line operating in the megabit range or above, and that you have a very powerful desktop workstation capable of doing lots of things at once. That isn't necessarily true in the real world. In fact, for the most part, it's not. So we're trying to make sure that you get fast, friendly, robust, and smooth behavior across a whole wide range of platforms, including all the common desktop environments. We are integrating security into Netscape. We're licensing technology from RSA Data Security Inc., which holds all the patents for a class of encryption and authentication technology called public key, which basically is the ideal approach for security, the ideal approach for allowing private activities to be conducted over open networks. We're trying really hard to be really compatible and, like I mentioned, free to internet-connected end users. This same product, this same program will be available in commercial form several different ways. We expect through hardware OEM arrangements. We expect through retail channels, and we expect in other mechanisms for distribution. But our goal in general is to get millions of copies in use as quickly as possible and to really start enabling the market for lots of commercial services to come online. So the flip side of that is the commercial-grade server software we're developing for the back end. We're building a hypermedia server line geared for commercial applications. Today that means using Unix as a back-end server, but I think that's going to be changing fairly rapidly. We're trying to make sure that our server software is quite a bit more friendly than people are used to. So we've built it so it's very easy to install and maintain. In fact, it uses Mosaic or Netscape as its front end, so it's actually fairly straightforward to use. It's very efficient, it's robust, it handles heavy loads fairly well, and it's also available with and without security, so you can buy or use our client, which has security built in, and then the servers either do or don't have security, and the client can talk to both types depending on what you're trying to do, or using the same security protocol, other people's implementation of the same things. And again, backward compatibility with the existing environment is very important to us. So one of the things we faced early on when we were starting the company is that a lot of people are really interested in this technology and want to do really interesting things, but this is also new, particularly the commercial applications, that it's not immediately apparent how to just pick up a server and pick up a client and do something interesting. So we are, this goes into some detail about it, but we're basically doing specialized targeted vertical projects for certain large customers to sort of just try to bootstrap the entire environment, try to get things up online as quickly as possible, and then feed the results of that work back into general products. So I expect within a year or two, you'll start seeing available from a number of companies, including us, the corner pizza store in a box, where it's just a template-based system where you just put up your pizza store, or you put up your flower shop, or you put up your bookstore. I think this is what that's leading towards. It's going to be interesting when it arrives. Here's where I really start waving my hands. Over the next year or two, where do I think this is all going? Like I said earlier, I think you're going to see a really rapid evolution of the functionality. I think we're only 3 or 4 or 5% of the way there in terms of what people already know that they want out of this environment. And then once we get to the 100% point, they'll already know 5 or 10 times as many different features and bits and pieces that they want to be able to do in this environment. Diversification of platforms, whatever happens in the general industry, I think this is going to adopt and evolve to span across it. Particularly on the server side, I fully anticipate people will be running servers out of their homes on their Windows boxes in the relatively near term. In fact, it's going to be interesting to see. Right now, there are many more clients in use in the network than there are servers. For a number of reasons, but as it becomes easier and easier to provide services and content to the network, it's going to be interesting to see if the number of servers starts to approach the number of clients, if everyone is providing information as well as sucking it down. Dramatically extending the back-end functionality is going to be a major piece, up to and including, like I was referring to earlier, turnkey systems for specialized online content and services. Be able to buy an online component, an online service in a box, and be able to tailor it to your specific business or your specific application, but not to have to completely reinvent it. Increasingly explicit two-way communication capabilities in a variety of forms. I think you'll be doing conferencing, email, and all kinds of things like that in this environment. You really won't have any reason not to do it in this environment because it's tied in with all the other information resources that you're used to having at your fingertips. And in general, this is kind of abstract, but opening interfaces all over the place to tie in all kinds of other services, systems, architectures. The big advantage of this system is that you can tie into whatever other type of system you want to. You can have anything on the back end. You can be talking to other servers across the network on the back end. And I think we'll just continue to open up all kinds of different ways to interconnect the different pieces. An interesting aspect of this, for example, is that Lotus has announced that it's adding web and Mosaic support to both its front end and its back end for its node systems. And that's interesting because your corporate collaboration system in a large company should then be tied into this overall environment. I think that'll be happening fairly quickly. Beyond that, over the next few years, far richer interactive capabilities. This sort of ties in with the fourth bullet, actually, final merging of multimedia and online experiences. I don't see how the multimedia industry, as a whole, is going to just be merging with this, meshing with this in the relatively near term, because they're both sort of colliding. The classic multimedia approaches need to involve communication, and the classic online services need to get much richer in how compelling they are and how involving they are to people. Much deeper integration into the desktop environment. This type of thing will just become a natural part of what you do when you're using a computer, when you're on a system, when you're communicating with anybody. All kinds of capabilities for searching, sending out agents to find information for you, various forms of intelligent assistance. People always talk about the flood of information and how important it is to have ways to automatically find information and so on. Ironically, the big problem up until now, I think, has just been that there's been all of these different systems, all of them disconnected, that have all kinds of information in them, and there's no way to search across them. In this environment, finally, we see, I think, that maybe if all of the information is accessible through this common front end, then we have an environment where it really makes sense to start to do searching across the entire system from information sources from all over the place. I think graphical immersive navigation is going to get very interesting in the near term as people try to figure out how to, it is an interesting problem. How do you navigate through an information space that spans all 7 continents and all the industrialized nations and tens of thousands or hundreds of thousands of servers? I think we should merge Mosaic and Doom. I'm not sure if that's the answer. Finally, and here I really end wave, full convergence with all the other mechanisms that are commonly in use for information, communication, interaction into a fully interlinked general environment. And that's my presentation.